This is section 5.4, day 2, and today we're going to be talking about the last sum and difference formula we have, which is for tangent. Just to note, when you're looking at your formula card, you have a plus minus here, so it's accounting for both of these formulas. And then on top you have a matching plus minus, but then on the bottom, upside down, you have a minus plus. So it's trying to draw your attention to, if you have a plus in there, you'll have a plus on top, but you'll have a minus on the bottom. So the bottom sign is the one that switches from what is in your parentheses for your angle. So we're going to do the tangent, find the exact value of the tangent of 75. Most times when kids or when I have students pick this, they usually pick 45 and 30. So that's the one I'm going to go with. And then I'll show you some advantages to the type of angle you pick when you're picking tangent. So we're going to start off with the formula. We put a plus in here. We did 45 plus 30, so I'm going to have a plus on top and a minus on the bottom. So tangent of 45 plus tangent at 30. And then I'll have 1 minus tangent of 45 times tan of 30. So the tangent at 45 is 1. The tangent at 30 is square root of 3 over 3. Then on the bottom, you just have those multiplied. So 1 minus, and then you have 1 times square root of 3 over 3. Up top, I'm trying to add together these two things. In order to do that, I will need common denominator. So I'm going to put a 1 under there. The common denominator would just be a 3. I don't have to change that at all. And then I would just have to make that be a 3. So I've got 3 plus root 3 over 3 over. On the bottom, you've got a times by 1, but that doesn't really do anything. So I'm just going to take that out. And then again, I would need common denominators. So I'm going to put a 3 there. So I've got 3 minus root 3 over 3. When we have stacked fractions like this, or fractions on top of fractions, we need to flip the bottom and bring it up. So 3 and 3 minus root 3. So I'm flipping this fraction, bringing it up to the top. So all of this should cancel. And now I'm looking at just a single level fraction, which is kind of nice. These two 3's cancel, and I've got 3 plus root 3 over 3 minus root 3. So not bad. But in order for us to find the exact value, I need to get rid of that square root on the bottom. So algebraically, we don't allow that to happen. So we are going to multiply by the conjugate of this, which would be 3 plus root 3. And I have to do that on the top and the bottom to keep my fraction equivalent. Remember, you're just doing the conjugate of the bottom. That's where your issue is with the negative square root of 3 on the bottom. So we're going to change that to a plus, and now we're going to FOIL this out. And I'm going to have to come down, kind of wrap it around here. So on top, I'm going to have 3 times 3. Then I'm going to have 3 times root 3. Then I'm going to have another 3 times root 3. And then I've got root 3 times root 3, which is root 9. And then that will become just a 3. On the bottom, I've got 3 times 3, which is 9. Then I've got 3 times root 3. Then I've got negative 3 root 3. And then I've got negative root 9. So don't cancel anything. You can't cancel those 9s. We just have to stick with simplifying our numerator and then simplify our denominator and see where we're at. So I've got 9 plus, and I've got 2 of these, so I've got 3 of them and then 3 more of them, so that gives me 6. And then root 9 is a 3. On the bottom, I've got a 9. I've got a 3 root 3 minus a 3 root 3, so those cancel, and then I've got minus 3. So I've got 12 6 roots of 3 on top, and I've got 6 on the bottom. Everything is divisible by 6. So I'm going to reduce, and then this is the exact value of the tangent of 75. So I said at the beginning that there are some angles that are advantageous to choose, and some that are not as great. So when we were plugging things in, 45 was awesome. A 1, that's so easy. Timesing by 1, like adding 1. A 45-degree angle, any of the 45s is a smiley face. Those are good to work with. The 30s, I would actually give a sad face to. It's kind of annoying that just using that tangent value was already a fraction, and then I had to put that fraction inside of a fraction, and it just made this really big problem that we had to deal with for a while. If you can use your 60s, those would be a much better option. All of the 60s are some value of square root of 3, so that's a lot easier to deal with than square root of 3 over 3. Introducing a fraction into our fraction formula kind of created all this extra work. If we can stick to a 60, which is a plus or minus square root of 3, then I don't have any fractions, so you're just putting that value in. and the 45s are all plus and minus 1s. If you are able to pick a 60, you kind of start the problem from right here. So you'll get something that looks like this, you'll multiply by the conjugate, do a little foiling, and you're home free. If you pick a 30, you will always have to add add with common denominators first, then you'll have to flip the denominator, bring it up. So it just adds a couple of extra steps of work. Again, if you can stick to 45s and 60s, you kind of enter the problem right at this stage, multiply by a conjugate, and then go.